All right, guys. So for Skittles and M&Ms, you should have your proportions written down. So you should have your fractions. I'm going to do this real quick so that I have some numbers to demonstrate with. Oh, come on. There we go. So this is my Skittles. On mine, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 50 for my Skittles. And of course, it took my thing down. $10 out of 50 is what percent? 20%. So I'd have 0.20. And then you want to do the same thing for your M&Ms. You're going to get the proportion of orange. Just give me. Yep, it just drew them different. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I only have 9 this time. 9 out of 50. 9 out of 50 is what percent? 18%. So now you're going to do the difference. Skittles minus M&Ms. So on mine, I'm doing 0.20 minus 0.18. So I've got 0.02. You need to find that for yours. And then we're going to make a dot plot up on the board. So you guys are going to have to come up to the board to put your dot. More than one person can put a dot at the same time. The board will take more than one finger print. Like, it's very, very touch sensitive. So I'm going to come up here. I'm going to put my dot. Yep. This one? Who put this dot up? The one that's right here. You put that one up? What was yours?
Not that.
Negative 0.1. So it should be, you got 1% difference? You had 9. So that's 18% and 28%. So 0.1, not 0.01. 10%. Okay, so let me move that dot real quick. That guy should be at negative 0.1, which would be over here. Come on, pen. There. Oh my goodness, it's not wanting to go in the right spot. There, close enough. There we go. I think that's what's happened to most of the people that are like, I got an odd number. Like, no, not quite. All right, so copy this down into your notes, please. What do each of these dots represent? What do each of these dots represent? This is kind of a hard one, right? Yes. All right, so this is our sampling distribution of p hat 1 minus p hat 2. Each one of these dots is showing us a p hat 1 minus p hat 2. So let's go ahead and write that down. This is the difference in proportions. Because we subtracted, that's why it's difference. Difference in proportions of orange candies for one sample of 50 Skittles and 1 sample of 50 M&Ms. Whew. So we have a very interesting dot plot. I want to see some predictions. How would you predict if we did this over and over and over again? What do you think the shape of the distribution would be if I had you guys each do this 5 times instead of just once? Looks like it'd be skewed left from that dot plot, right? Where would you guess the center to be? At about where? In between 6 and 8, so over here somewhere? Let's see, how many dots we have? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Probably a little bit further over, but right about. So I'd probably put it at about 0.3, just counting dots and going off the median, which I know is not the same thing as the mean. But if I'm thinking about the center, I don't want to calculate the mean on this right now. So somewhere between like 0.6 and 0.3, right? What do you think about the variability? Looks pretty large, right? Like if I asked you to guesstimate a number that you thought for the standard deviation for the spread. If we put our center, say here at 0.3, let me go ahead and draw a line there so we can see it. If we said this was our center, standard deviation, remember, on either side it's going to grab 68%. That's our empirical rule, 68% of all of our data. So we want to grab most of our dots then, right? So something like this. How far over are we going from 0.03? How much? 0.07. Awesome. Okay, so looks possibly skewed left. Center mean about 0.03 or 0.06 was what we decided. Standard deviation about 0.07. All right, let's flip this over. Google search. I love Google. Google search revealed that according to the Skittles company, I don't remember what company owns them, but the company that owns Skittles says that 21.6% of all Skittles are orange. And 20% of all M&Ms are orange. I want to describe the sampling distribution of the sample proportions of orange for Skittles and the sampling distribution of the sample proportion of orange for M&Ms for samples of size 50. So if I'm thinking about my population of Skittles being all Skittles, what do you think the overall shape would be? How would I check to see what kind of a shape I think I've probably got? Large counts. So let's check our large counts. If it meets my large counts condition, then that means it's approximately what? Approximately normal. Large counts. So n times p needs to be greater than or equal to 10. N times 1 minus p needs to be greater than or equal to 10. For Skittles, what's my p? 0.216. What's n? 50 for both of these. 50 candies times 0.216. What do you get when you do that? How much? 10.8. Is that greater than or equal to 10? Cool. Do the same thing for n times 1 minus p. So 50 times 1 minus 0.216. What's that one come out to be? 39.2? Greater than or equal to 10? Yep. So that means that my Skittles would have what shape? Approximately normal. I want you to check large counts for M&Ms too. Are my M&Ms approximately normal? Yes. What is n times p for them? 10. Greater than or equal to 10. It meets it. It's right there, but it meets it. What is n times 1 minus p? 40, which is greater than or equal to 10. So this one is also approximately normal. Mean. How do we calculate the mean for a proportion? Yeah. Mean, we're going to call this p hat 1. Or I could call it PS for Skittles. It's equal to whatever the proportion is for my population, which is how much? 0.216. That's my population proportion for my Skittles. What would that be for M&Ms? 0.20. How do we do standard deviation? You might need to flip back a page and look at that. How do you do standard deviation for a proportion? Yes, square root of p times 1 minus p over n. So we're going to do 0.216 times 1 minus 0.216 over 50, and then square root it. I want you to do that for both Skittles and M&Ms. What is our standard deviation for Skittles? .0582. And for M&Ms? 0.0566. Number 6 says, describe the sampling distribution of the difference between the proportions of orange Skittles and M&Ms. So x minus y. Well, if x is approximately normal, my Skittles, and y is approximately normal, my M&Ms, what do you think the shape would be for the difference between those? What'd you say? It's going to be approximately normal. The shape will be approximately normal. Because x and y are approximately normal. Which we got to by our large counts. How would we calculate the mean of the difference between the proportions? Any thoughts? The mean of x is 0.216, the mean of y is 0.2. How would I find the mean of the difference? Yes. Close. That'd be my standard deviation. What about for my mean? Just subtract them. So the mean for x minus y is going to be equal to the mean of x minus the mean of y. So 0.216 minus 0.2, which would be what, 0.016? For standard deviation of x minus y, we studied our random variables here. So I need the standard deviation of x squared plus the standard deviation of y squared, and then square root that. So I'm going to take those two standard deviations, 0.0582. We're going to square it. We're going to add that to the other standard deviation, which was 0.0566. We're going to square it, and then we're going to square root the whole thing. Remember, whether it's a difference or a sum with my random variables, on the standard deviation, you always square and add, and then square root. Always square and add, then square root. When somebody has a value for this, could you please call it out? 0.0812. There was a calculated difference in proportions of 0.08. I want to calculate the probability of getting this difference or higher. What did we say the shape of this difference would be? Approximately normal. So what are we going to start this off with? Approximately normal. Draw me a picture. What goes right in the center? What are we going to put right down the center of the picture? The mean. So 0.016. Then we have our standard deviation here of 0.0812. N with 0.016, 0.0812. That's my mean and my standard deviation. So I just start off with my picture. Now I care about what I'm seeing right here. Where would this go on the picture? To the left or to the right of the mean? To the left, it's smaller. Or to the right? Is it bigger or smaller than this? 0.08 is smaller than that. Think about it like money. 0.01, that's like a penny, right? 0.08 is like 8 cents. Which one's bigger? 8 cents. 0.08 is bigger, so it's going to go on the right. So 0.08 is somewhere over here. It says 0.08 or what? Getting this difference in proportions or greater or higher. So this is what we're looking for the probability of. How would I calculate that? First of all, what does my probability notation look like for something like this? All right, so probability notation has to start with what? Big capital P. Then parentheses. We have a difference in proportions, right? So P hat Skittles minus P hat M&Ms. I want to know the probability that the proportion of Skittles minus the proportion of M&Ms is bigger than or equal to 0.08. Normal CDF. Inside my parentheses, what should be the first number? What'd you say? 0.08, that's my lower bound. And then we need a comma, and we put in what? Big number. How about 1,000? There's my upper bound. What comes after that? The mean, 0.016. And after that, standard deviation. And I need to buy myself a little bit of room to do that. And then you calculate it. So while I'm scooting this over, I want you guys to calculate it. What do we get? What do you say? 0.2153. So is their result surprising? No, why not? Greater than 5%, it's greater than 0.05. So even though they got a difference in proportion that was a good bit higher than the mean, it's not a surprising result because it still happens 20% of the time, 21% of the time, just by chance. Not surprising enough. All right. We have flown through a lot. So I want to kind of recap what we just went over. And I can go back to any of these screens if you need me to. But to recap what we've just done, sampling distribution of p hat 1 minus p hat 2, it's approximately normal if both of my proportions pass large counts. So my sample for proportion 1, my sample for proportion 2, if I pass large counts on both of them, so both of them are approximately normal, then the difference is approximately normal. Center is P1 minus P2, population proportion 1 minus population proportion 2. Variability, I want the variance, so P1 times 1 minus P1 over N1, plus the variance, P1 plus 1 minus P2 over N2. Sorry, I think I said P1 there, P2. And then square root it. These formulas are on your formula sheet. But you still need them so that you can do the homework tonight. Normal calculations. You can do this to find your z-score, then you got to look it up on table A, or you can do normal CDF on your calculator. Lower bound, upper bound, mean, and standard deviation. I want you guys to try the check your understanding. See what you can do with those 4 parts there. I want to know the shape, the mean, the standard deviation with an interpretation, and then I want you to find the probability on part D. If anybody needs me to go back to a previous screen because you weren't done getting the notes down, please let me know and I'm happy to go back. Take about 5-ish minutes to work on the check your understanding, and then we're going to compare. This is very similar to what we just did on page 12. Mm-hmm.
So if you can like a decimal for like the percentage of like so out of the 30 people, we know like 42%. So let's multiply 30 like 0.42 just to see. So you get like a decimal. I just said that's like 13.
Write that.
Just 12.6. Oh.
Because what you're checking is to see if it's bigger than 10. Is it 10 or bigger? As long as it's 10 or bigger, I don't care if it's a decimal.
Oh, okay. And then we just subtract it, right?
You got to check for both. You do n times p and n times 1 minus p.
Oh, okay.
For both of them. You don't do any subtracting to check your shape. Except for the 1 minus p part.
Would I have n as 30 or n as 31?
Which one is your sample?
30, right?
Yep.
Okay. And then the proportion would it still stay the same as 65%?
65% for seniors.
And then 30 as the sample.
And what about for your other one?
It would be 30 juniors and then 42.
You got it.
I'll take it off.
That's okay, I got it. What is the shape for the difference in proportions? Approximately normal. Why? Yep. Meets the large counts for both of them.
So that's what we have to say, like, they meet the large counts.
Yep. You got to show your work, and then you say that it's approximately normal because of my large counts condition. What is the mean of the sampling distribution? 0.23. You do the population proportion for population 1 minus the population proportion for population 2. So 0.65 minus 0.42 gives us 0.23. What is the standard deviation? What would the standard deviation be? Does anybody have a calculation for standard deviation?
0.1253.
Yes, 0.1253. Did 0.65 times 0.35 over 30, 0.42 times 0.58 over 30. So P1 times 1 minus P1 over N plus P2 times 1 minus P2 over N, and then square root the whole thing. My interpretation of that, the difference in sample proportions for people who have a parking pass typically varies by about 0.1253 from the true difference in proportions of 0.23. Let me pop that up just a little bit higher on the screen so you can see it a little bit better. How would we go about answering part D? Like, what do you have to do to answer part D? You got to draw your picture first. We have our mean, we have our standard deviation. We know it's approximately normal. So we're going to draw our picture. We wanted to know the probability that the difference in sample proportions is greater than 30%. So then I would have capital P, P hat 1 minus P hat 2 is greater than 0.3 is equal to, and then I would do my normal CDF. Lower bound, upper bound, mean and standard deviation. So when I'm talking about proportions, I realize my upper bound is kind of small. I didn't put in 1,000, I only put in 1. Because proportions are the same thing as percentages, right? Well, what's the biggest we can have as a percent? 100%. So that'd be the same as 1.
Yeah.
So when I'm talking proportions, my upper bound, 1 is a big enough upper bound for proportions.
So anytime we have proportions, is usually
You can if you want to. You can always use 1,000 if you just want to get in the habit of doing that too. It's certainly going to be less than, 10,000%. You should have gotten about 0.2877. 0.2877. I'm going to give you guys a couple minutes to finish getting this copied down into your notes so you have it for reference. Homework 7.2 is due tomorrow. 7.2 homework due tomorrow. Dealing with sample proportions and differences in sample proportions. Absolutely, you may. Does anybody else need another copy of the homework as long as I got them out? You're welcome. Does anybody else need another copy of the homework? Great. Well, I hope you guys have a fantastic rest of your day. And I will see you back in here tomorrow.